Hello, and welcome to this session on Hello MARV. And over the next hour, I'm going to teach you a little bit about how we can use, or how we have been using Edge Impulse's AI and ML framework to create a robot. So our application for today that we want to create is we're going to develop a machine learning system using the Sony Espens that can really be deployed and identify crops. And to be honest, we can train this and use this to identify anything. It doesn't have to be crops, it could be anything that you have in mind. One thing I will say before we get too far into it is this session is we're actually doing a live session as well here at Anglia Ruskin University. So if you see me drop off camera or something, it's while I'm talking to or working with some of the people that are floating about and have got the hardware and are trying to hopefully follow along for today. So really what I wanted to show you about is the first thing is, what is MARV? So actually MARV is a robot. You should be able to see it now on the screen. It's this big white framed vehicle, and it's actually a crops trials robot. So it's designed to not pick crops or process crops or anything like that. It's designed to support crop trials. And if you understand about some of the challenges that agriculture faces around the world and ensuring that we can continue to support and help our growing population, then trials robots are quite interesting to help us work out how to get the best from crops possible. So what's quite interesting about the MARV robot is, if you can see along the bottom, there's a lot of these yellow little modules, and it's designed to drive down a row of crops and to actually irrigate those crops with a set amount of irrigation. And it also has to do the other thing as well, which is to remotely monitor each individual crop as it's going through its life. So from when it starts as a seed and when it's germinating, all the way through to the end when it's actually, when it's actually being ready to plot and we're being ready to take away and look at it. So this is the robot that we built, and it has two modes on there. So we have a spraying mode on there, and we have the imaging mode where accuracy is key. So that's the most important point today. What we decided to do was we were looking at this and we needed basically a processing solution for this. So we picked a Sony Espens development board, and that comes with an extension camera and a module. You get the three little bits. Some of you will have got the hardware today, and that hardware will have been shared and sent about. And we've got people in the room with hardware. And what it consists of an expansion board, the Sony board itself, the development board, and the all important in this case, the little camera that we're going to use to get started. Now today, actually, we're going to do a bit of a hands-on lab as we work through this. So hopefully everybody's managed to set up accounts with Edge Impulse and such like. And what we'll do is I'm going to walk you through how to do this. So the first thing that we want to do actually is we want to go to get the data set. So the data set should be available. On the and we got it from Kaggle, and there's a link in there to the data set. You might have to register. You might have to give it your IP address or something to it, but you can register and download this application, and it will download a little agricultural crops data set that we can then begin to use. Once you've downloaded it, it'll actually come down as an archive file, essentially. So it'll come down as a zip file. And what we want to do is we want to extract that zip file if you've got it, so that we can see what's in the file. So I'll give just a couple of seconds for everybody to download it. I don't think there's, and if they get, well, I should say as well, if you get any questions or anything, please feel free to shout them out, and we'll take a look at them. Once we've got this data set, that becomes the next important, exciting bit that we've got with a data set, is we want to actually create the impulse. And this is where we're going to use Edge Impulse to actually begin to create our application. And we're going to go through it a couple of times. The first time we're going to go through it, it's going to work, but it's not going to be quite as accurate as we'd like. And then we're going to look at what we can do to optimize it to give it a little better optimization and move it through with that data set as well. So creating the impulse is actually quite straightforward, and I'm going to try and follow. I've already got the data set on my machine, so I'm going to follow along now, and I'll actually do it live on this machine while Jeff scrolls through with the slides. So what I'm going to do is I'm going to click on in Edge Impulse. I'm going to log into Edge Impulse, and then I'm going to give it a name for the project. So I'm going to call this Imagine Live in my case. And once we've done that, we're going to click on Create New Project. So what you should see is that will come up very quickly and tell you that it's created a new project. It should be nice and quickly created for us to go from there. Once we've got that, what we'll see is that it opens immediately into what kind of project do we want to create in our Edge Impulse. So this is really nice and really one of the things that makes it really nice and really simple when we're using Edge Impulse. Edge Impulse is kind of done for machine learning and AI what Arduino did for embedded systems, and sort of making it really easily, really accessible and really open. So what we're going to do actually, we're going to tell it today that we want to do an image-based solution. So we don't want to do an audio processing or accelerometer or something slightly different if we want to. In this instance, we're going to go with images, and then we're going to tell it that we want to classify or detect just a single classification. So we're not going to tell it that we want to do lots of different types of classification. We're going to tell it we just want to do a simple single image classification. And that makes it nice and simple because these boards that we have, I should open one up. These boards that we have, these little boards, where are we? That's the camera board, is it? That's the camera board. But those little boards, they're not running. They can run like sort of NUTX or bare metal OSs and low-level OSs, but they're not really capable of running sort of a Linux-based tech stack. So we have these boards, and once we've done that, what we can do is we get some options. And although I'm not going to go through it today, I've actually, if you look at my website, there's a couple of other projects where we've done this as well with connecting to a development board. And if you want to, you can literally connect your development board directly to the Edge Impulse server, and you can capture images or capture data and load them direct from the camera on here, straight up into your system, and then you just type them as to what you want them to be. You know, good image, bad image, apple, orange, what are the fruits we're looking for? Wheat, grass, sugar cane, and such like. Or you can do what's the really important thing actually in a lot of our applications where you want to do machine learning is where you can find that existing data to input. So you find that existing data set like we found today, and that's what we're going to do. We're going to click on the import data set, and this should open up with a nice little box to allow us to then think about uploading the data. So once we've done that, what we need to do then is the key thing about machine learning in this instance is we need to give it a tag. You know, we need to put our data sets up there. We need to give it a tag, whether it's healthy or unhealthy, apple or orange, such that we can tag these images and they can be associated and work with each other and process. So what we're going to do, in this instance, we're going to go to choose files, and then I'm going to try and navigate to where I keep my files for this, for the Sony one. I think was under here. Oh, no, wrong place. Where did it go? Where did I save those files? They've gone somewhere now. They went to. So we need to find, the key thing is we need to find these, and then what we want to do is we want to tag them and upload. We want to tag them and upload them. So what we're going to do is we're going to select the files and the documents. We're going to select the files, from where we've downloaded, and they're going to be under crop images, I think. And then we're going to select the different types of crop images that we've got. So we're going to detect, say, for instance, the maize ones. We're going to come in here. We're going to see all the maize images. I don't know if I've put them in there. We're going to detect all those. We're going to select them by doing just Control A, and then we're going to click Open. And you should see there's quite a few files in there, and we want to enter a label. We don't want to let the tool infer from the file names. We want to enter a label ourselves. And since I've just uploaded the maize ones, I'm going to just type in the word maize as my label, and then click on Begin Upload. And what you should see is this really quickly uploads the files. If you happen to have put any duplicate ones in, then it will automatically sort of say, well, you've already duplicated that one. That one's already in the system, because you can see it checks the hash of everyone as it's uploaded. Now, what we need to do is we need to do that for each one of the files that we want to upload. So we need to do this for the maize, for the sugarcane, for the wheat, and for maize, sugarcane, wheat, and rice. So once we've uploaded those, rice, it takes a few seconds to upload them all. It's quite quick. The network here at the university is actually quite quick today. That was sugar, I think. And then finally, we're going to do wheat. So once we've got this, we can see that this is bringing through and pulling through and uploading all of the files into our Edge Impulse system. It doesn't take us too long. Obviously, if we've got a larger data sets, then it might be tricky. But actually, what we want to do then is we want to take a look at the data acquisition. So if we go onto this tab here, if we go onto the right-hand side, the drop-down menu where it says Data Acquisition, and click on Data Acquisition, we should see we've got a fair few lines, a fair few types of crops uploaded, and we should also see that we've got it split automatically between the test set and the training set. So the training set is going to be used to train the neural network and detect what's going off in that neural network. The test set is obviously what's going to be used to test that neural network once we've actually created it and implemented it. So it makes it nice and simple if we don't have the two together and we don't pull them together quite closely. So now we've got this, we're in a position that we can begin to actually then create our impulse and do our training and train the neural network and see just how accurate it is or not. As the case may be, we might train it the first time around, and it might not be able to tell the difference between sugarcane, wheat, and such like, as we're about to see whether it can or not. So what we can do then is we can click on the impulse design over here on the edge. And if we click on this, you'll see it opens up a nice, simple little block diagram sort of graphical thing. We're not going to write any code in any way, shape, or form today. All we're going to do is just use the flow that comes with this edge impulse flow. And you can see then that we've got some image data that we've said that we want to bring in, and then there's a couple of gaps in the middle where we want to add a processing block and then the learning block that's going to do our learning. So if we've got any chat requests. Okay. So let me just put this in the chat request for the cable data set. There's a link here. So there's a link there to the data set. and I'll stay looking at the camera because apparently everybody online can't quite hear me if I turn away. It's in the Zoom meeting chat. I will send that link to you in a second because no, you're not. So if you give me 2 seconds, I will put that in a. If you go to kaggle.com, so KAGGLE.com, and you search for agricultural crop images, then you should be able to see the agricultural crop images, I hope, and find that. It's also on the YouTube. So if you quickly Google YouTube, you can find the live stream for this, and the link will be in the chat on YouTube. Okay, so now we've got this downloaded. What we want to do is we want to take a look at our image processing and work out what we want to do in terms of our block, so we can get our blocks going. So what we're going to do is we're going to create a nice and simple impulse here, and we're going to do this by the first thing we're going to do is we're going to click on the add a processing block. So on this element here, we're going to click add processing block. And what we're going to do from the drop-down menu is we're going to select image. So we're going to click image, and that's going to pre-process. Our image as we want it to run through. The next stage then is we can click on the add learning block. So this is the actual learning block that we're going to implement our machine learning on, and we're going to click on the transfer learning at the top and click on add. So now we've begun to get the basics of our system, and what we're going to do is we're going to save this. We're going to save this impulse. So if you're following along, we should be on step 16. And what we're going to do then is once we've got this, we're going to click on the image option. So we've now created our impulse, but we might want to do some manipulation and change and do a little bit of setup with our image. So what we're going to do is we're going to click on image, and what you should see then is an image with some raw data on there. What we're going to do is we're going to scroll down to the bottom. Oh no, first we're not first actually. We're going to go back to the dashboard because one of the things about doing machine learning is obviously we want to know how long it's going to take on our system in terms of what the latency is when we're processing a frame or not. So what we can do is if we come down to this, come down to our dashboard down here at the bottom here, we can actually select our target board. So we can select the Sony, and then this will give us a more up-to-date calculation as we're working through this as to what actual application that we're looking at, what actual the latency is likely to be through our system. Once we've done this, we're going to click back on the image itself, and you should see up the top. You should see an image from the from some raw data. So maybe, for example, from some wheat or some crops. It depends on what one you loaded in. Now we're going to leave this as it is. We've got the option to change the color depth, but for this time we're going to leave it unchanged. You'll notice that we're now predicting. We have this on-device performance down the bottom, which is showing 5 milliseconds. So it thinks it's going to take about 5 milliseconds to do a classification and to run through this, and it's going to use about 4 kilobytes of RAM. And as we move through this, we'll see this prediction update and get a little bit better and a little bit more accurate. So what we're going to do now, once we've clicked on this, is now we've got the image and we've said whether we want it to be in the run through and pick anything up. So that's a good point to pause, I guess, and ask if there's any questions so far from anybody that's attending, either in the room or on the Zoom link or on the YouTube link. If there is, Alessandro, just pop them across, we'll take a look at that. But it shouldn't take too long now for this data set to run through. And once we're done, you'll see here it comes out that the job's completed at the bottom. So what we're going to do now is we're going to click on our transfer. We're going to click on our transfer learning set, and we're going to leave the number of training cycles the same, and we're going to leave the learning rate the same as well. So there's a couple of people asking about sharing the slides. So I will share the slides afterwards as well, and I'll give you a link to a video walkthrough as well, where this is working through, or you can watch back and watch this recording as well. So the slides are actually, they're on my GitHub as well as we at the moment, which is A Taylor CNJFIET is the GitHub tag. So once we've got this, what we want to do then is we want to click on the start training. We're not going to make any changes at all. We're going to click on start training, and this is going to take a few minutes. So while it does, I will just get you the link to the repository where the slides are for the time being. So there you go. So if you go to the GitHub link I've just put in the chat, and Alessandro, if you can pop it on the YouTube channel, then people can find the instruction slides there. Can find the instruction slides there anyway. Now it must be slow today because everybody's running through it, but it's normally quite fast to this. So this is doing the training of the neural network. Obviously, it's using the Edge Impulse server, so it makes it nice and quick. We're not doing anything on our desktop machines. You know, it's picking up and running in the cloud, as you can see. So you can get a lot more horsepower, obviously, from the GPUs and CPUs and such like that are on that server back there. So once this is done, this should give us an estimation of what we think our model is like, and what our accuracy is like on the system. And that's going to tell us, we're going to get this nice performance, this nice training matrix, which is going to show us what we've got in terms of the ability to differentiate between the different types of crops. So it's going to be able to tell us whether it could, using the training set, whether it could tell the difference between, say, sugarcane and maize, or maize and wheat. And as you can see, as it's running through this, it starts out obviously with a floating point model, you know, a fully floating point model, and then because you're deploying on the edge on MCUs, which although very capable, you know, you get the best performance out of them using fixed point integer. It's converting that into an int8 model, and that's then running on the board. So as we'll see, it's nearly completed training, we hope, and we'll come back through and we'll see in this instance, on my one in the office, it's actually a lot lower, but we'll see that it's come back with this confusion matrix down the bottom. On the live slides, it looks a bit better, where we're seeing about a 72% accuracy in the ability to tell between the different types of crops that we're seeing, which is not really good. Our clients aren't going to be very happy if we can't tell the difference between these crops. So we want to do it a little bit different and a little bit better, and try and improve the performance that comes with that this analysis and this machine learning. So what we can do is we can go back to our impulse design where we created our impulse. We can go back to the impulse design, and within that impulse, we can make a few things that we want to do if we want. So we could change from the fit shortest axis to squash or whatever if we wanted to sort of scale down and squash the image a bit. We can also, on the next slide, we can also take a look at the image itself, so the image processing element itself. So we can click on the image and take a look at that image transfer. And perhaps we could change this from, we don't really need, to be an RGB. It comes with 3 color channels that we've got to process, red, green, blue. And we've obviously that takes a lot more computational process. And actually, a lot of the information is contained within the luminance channel anyway of these images. So we're going to change this to a grayscale image. And then we're going to generate the features again, because now we've told it slightly different. So we're going to save the parameters in this application, and then generate the features for the next time. So if we click on generate features, it should take a little while to generate these features and to run through again. But this time it's creating the features that we want in our system that are actually hopefully going to provide us better information, provide the machine learning model with a better optimization, and make the machine learning model a little bit more accurate and timely. Now, when that's done, we can see we'll get the Explorer up again, and we can take a look at the visualization and the clustering of data. But the next thing we have to do again is then do the transfer learning again on the image and train the neural network again. So this time we're just going to click on start training again, and hopefully it's going to run through and start training, and it's going to come back. Not sure about the live demonstration, but certainly in the lab example, it comes back with a lot better accuracy. It comes back at about 96% in the lab one. Perhaps not the live demonstration one won't be there. But if anybody's got any questions, now's a good time to ask while this transfer learning is going off. What I'm going to do is I'm going to quickly open one of these boards. So if you did get one of the boards, what we need to do is we need to open them up such that we can use them if you followed along so far. And all we need is these 2 boards. We don't actually need the expansion board. We just need the main processor board and the camera board. And then what we can do is we can open these up. Nice and sticky labels. Try not to rip everything. We can open this. We can open the board up, and you'll notice the boards are nice and tiny. And in that board, once we've got it, we should see a little tiny. Hopefully, you can all see that, a little tiny board like so. And then we'll open the camera up. Oh, very sticky. Get the camera opened, and the camera should just connect in relatively simple onto the system. So if we can all get this up and running, I can show a live demonstration of mine as well at the end of it all working. But this has run through so far, and it's just running through, and again it's just doing that conversion into the intake model again. Okay, so it's finally finished and it's run through. In this case, actually, in my one, it's got a little better. In the lab one, in the real world, in the lab one, the lab example, what you should see is that it is about 96-95% accurate if you've done it not in a rushed way, in a live way. What we're going to do then is we're going to assemble the camera and the little boards, and we're going to put this together. Fairly straightforward to put together. It just plugs in like so. Hopefully everyone can see that. If there's any questions, shout out. I'll show everybody around there. You can just put it all in. Plugs in there. And this is what we're going to do and use for the rest of our testing now, because now we've got a model actually that we think is good enough to begin with and good enough that we might actually want to deploy it onto our target. So we've got two options. We've got two options now. We can test the little design a little bit more in Edge Impulse and do some live classification, or we can actually connect to our boards and build the applications and run through a little more. Now, I did ask, if you're following along at this point, I did send out some instructions the other day as to what needed to be downloaded, the pre-link. So there were some elements about downloading the GNU Make, for example, and the ARM compilation tools. But if we've done this, then one of the first things we want to do is we want to open up and I'm going to switch my projects here. What we want to do is we want to open up a shell such that we can communicate and talk to and start the Edge Impulse application. So what we're going to do is we're going to clone this repository. If you've got GitHub, there's a link here, and I will pop it in the chat in a second. I want to clone. If you've got GitHub, we want to clone this repository. So at that repository, it's going to contain some Edge Impulse examples, and it's a standalone interface, the standalone software framework that we have for working with the Sony Esperance Edge Impulse board. Once we've done that, what we're going to do is we're going to ask the tool to actually give us, and this is one of the really nice things about working with the Sony boards and working with Edge Impulse and everything, is actually it gives us a really nice solution that we can take forwards and we can wrap up and pull together. And what we can do is we can go down here and we can click on the deployment option on the slides, and we get a range of things that we can ask it to give us depending upon what we're working on. So if you've got a specific board, for example, you can pick the board and say give us the firmware for this board, and it should be downloaded, and it'll download you a kind of a complete working solution for that board that's doing the classification that you want. Or if you want to be a little bit more flexible because you want to add in your own design and your own code around what's going to be created in the system, because obviously it's nice to be able to see it doing the classification and see it be able to do the working, but at the end of the day, really, the AI is, while a central part of the functionality, is going to be a fairly small part at the end of the day, to be fair, of the overall solution. So, for example, in our robotic application, we want to not only do we want to grab the pictures and do the classification, but we then also need to communicate with the rest of the robot and send this data back for aggregation and processing. So we need to do a little bit more software development and wrap up around the edges there. So what we're going to do to do this is we're going to click on the C library. I'm going to double click on C library, and then we're going to scroll down to the bottom, and you'll see that it tells you get some nice options down the bottom as to what you might be using or not using. So you can tell it whether you want the quantized and the optimized implementation, or whether you want the floating point implementation. And you can see, really importantly, you can see the difference between the two. So, for example, in this instance on this slide, you can see that if I want it to be if I want to use the optimized one that runs on int8 functionality, I can see that it's going to take me about 3.5 seconds from capturing an image to being able to classify that image and tell me what it is. If I run the floating point one, it's going to take me about 12.5 seconds to work out what it is. Now, the beauty of doing this is these devices, again, they give us this ability to because we're on the MARV robot, we're going to have multiple ones of these in lines with crops. So, and the MARV robot's going to be sat in a field in the middle of nowhere, normally in a remote location. Actually, trials aren't normally done in nice locations. So this is going to really allow us to sort of use a nice low power microcontroller, but still, if we use the optimization, the int8 optimized one, we can run through and we can do this in sort of 3.5 seconds. Now, it's not, you're not going to be able to, it's not like we're driving a car or something and trying to navigate the environment with this. This robot can just move slowly down the road, and it can actually then just get the information that it wants as it's slowly moving down the row of crops. So we're going to tell it to give us the quantized one, the build one, and we're going to just ask it to build. And you'll see it'll take a few seconds in the directory where it builds and it downloads. And it's going to ask us at the end of this where we want to save it to. Where did mine go? Mine goes under documents somewhere. Yes. So once it's done, it's going to pop up and it's going to ask you for somewhere to save that source code. So this is the source code that you want to save. And what we can do is we can find a nice safe location for this. I'm just going to store this one in my downloads directory actually, and click on save. And that's going to download us our C application. Once we've got our C application, what we can do is I'm just going to open once we've got that, what we can do is we can extract that model. And as we extract that, what we will see, is we will see 3 directories. So we'll essentially see a Edge Impulse software development kit, we'll see a model parameters and a TF light model. And we will see also a README as well, which is under the software example that we downloaded from the GitHub. So under the GitHub that we downloaded, you'll see that there's a file called readme.md. Now, if you take a look and open this readme.md, it will tell you all the commands that you need to be able to make and communicate with that board and flash with it and work and hopefully work with it. Now, once we've got that actually installed, we can do there's a few other things that we can do. We can try some of the live classification on the website as well. Before we deploy it onto the board, we can try some live classification. So what we can do is we can go back to our deployment, and we can check on here. We can check the live classification tab on this edge here, and on this live classification tab, this gives us the ability to pull through. Maybe, for example, we could connect to our device if we've connected to our device, or we could upload other sample images or sample waveforms if we've done it, and we could test that. So I'm going to just click one example at random and click on load sample. And what you should see then, if you get the results, is you should see hopefully a result comes out that tells you what it thinks it is, and what its classification is, and what its actual probability of classification is. So you'll notice that in the case on the demo, there's quite a high probability. You know, there's a 0.94 probability, not on this one on the screen. There's a 0.94 probability that it's maize compared to wheat. So we could be pretty happy to say that that's fairly high. We'll take that. We'll classify that crop as a maize, and we'll use that developing our robot a little bit more, and we'll tell the downstream applications that this plant is maize, which should be good. Once we've done this, I managed to break the screen there. Once we've done this, we've got a few other stages that we want to do, because now we've tested it in reality. The next thing that we want to do really is to test it on the board. So we want to create a little application on our board and get that working. So once we've done that, what we're going to do is we're going to go back to our application, to our downloads, where we've got the downloads that came through. And what we're going to do is we're going to find a file called eimain.cpp. So we're on step 8 now of the deployment slides. We're going to find this eimain.cpp. And if you open that and take a look at it, you'll see that there is this lovely, at the top of it, there is this lovely constant, for example, shall we say. And it's a constant, a static constant. It's just a large array, a very large array. And what we can do to test this on our board, we could do a real live test where we've got some crops and such like, and take a camera and take a picture of it. But actually, I'm in the UK now, and it's 6:45 at night, so it's actually pretty dark outside. So there's no real crops for me to go and take a picture of. And I'm actually in a city centre, not out on the outskirts where I might be able to find some crops. So what we can do is we can actually go back to our raw application, our raw data. So we can go back to our raw data, and you'll notice it says here raw features. So we can click on this, and it should copy these raw features into our clipboard. So it'll copy this into the clipboard. Once we've got this in the clipboard, what we can do is back in our back in our application, we can double click on this. We can double click on this line, delete it, copy and paste the data in there, and then we're in a position that we can build. That we should be able to build our application. So what we can do is we can open a command prompt window, and I'm going to try this live as well with everybody else. So we can open a command prompt window. Go to my document and find the demo area again. So this is a great question about which way to plug in the Sony board. So hopefully I plugged this in the right way around. It's getting a little dark. I plugged this in with the such that the blue ribbon, the blue ribbon element, is facing the back of the board, essentially. So when I plug these two in here, this is the front, and I put this in with the connectors in this way around. Which I hope is the right way to do it. You're not going to damage anything. If not, if you plugged it in the wrong way around, then you can change that connection anyway. And then we have the nice and simple assembled camera and board. We've got the USB to power it here, and that's what we need to do now. Is the next thing we want to do is we want to build this application. So what I'm going to do is I'm going to open on my laptop here. I'm going to open a command prompt. I'll open it with admin privileges. I'll open it with admin privileges just in case, and then I'm going to go to I'm going to go to the directory that we cloned the EI framework in. I'm going to change directory to that, and just to prove we're there, if we do dir, you can see that we've got all the files and everything that are necessary for it underneath there. And then if we type in the command make-j, this should run through and build it all. In my case, I've already built it, so it's already downloaded. But you can then connect your board. I'm going to get not long now. We're going to get a USB cable and connect the USB cable to the board, and then hopefully we should be able to see that the applications come together and it's all working, and we should be able to see and flash this. So if I never work out which way around to untwizzle the wire wrap thing. But yeah, so if we get this all undone, let's get this all undone. If we connect our board, apologies if you can see the top of my head while I just plug this into my laptop. and plug it in, we should see it come live. And then what we can do is we can type in the command flash, make flash, hit enter. And we should see it flash down into the device. Now, there's one thing I've noticed with this, in that sometimes if it fails, you might need to take a look at the make file itself and just change the baud rate on the USB link, and that helps a lot, because it's acting as USB RS-232 over USB. So if on the off chance that you do see it failing due to trying to run at a megabit per second or something like that, if you just open the make file and slow that down, then it will give it a little bit better progress. But what you'll see is that download and move into and program the device. You should see a little progress bar coming up at that point in time. So as you can see what's going off as you go down here. And if it, like I say, if it fails for any reason, just change that baud rate. But then once it's done, you should see it disconnect, and it should just start running. And once it starts running, mine's just done the same thing. Once it starts running, what you should see then, once it's downloaded, you should see it starting to download and run the actual impulse on your code. So it's running the C code. It's got that application in there, and you can see it's downloading the picture. So you'll see it running through, and it's throwing out over the RS-232 port. It's throwing out all of the information that's being made, all of the frame information that's there. So there's those constants that we copied into the design. But if you look through that, what you'll see when it finishes is you'll see a prediction of what crop you're looking at. And if you take a look on the next slide, please, Jeff. If you take a look on the next slide at the bottom on step 15, what you'll see is that it's actually found a lot of these images at the bottom, and it's done the classification correctly. So in the case of where we've put a picture of maize through there, it's correctly identified that, so we can pick that up and move that on and use it with our solution. So that brings us really to the end of this session just about. And what we've done is to just recap. We've introduced you to the MARV robot and said what we're doing with the MARV robot. You know, hopefully we're going to be able to do some nice agricultural work with this as the project develops and continues to build. And the Sony camera system is going to be one of the camera systems that we're using on there for this crop rotation and crop identification. I've shown you how we can take a data set and upload it into Edge Impulse. How once we've got that data set in there, we can identify and tag the data sets between different categories of things we want to do. How we can separate that between the testing and the training set, and then how we can create the impulse itself. So how we can create that impulse initially, and if that initial impulse doesn't come back and doesn't give us the results that we would like, then we looked at how we can go back and how we can look at a little bit to how we can look at that impulse, and we can change some of the parameters. In this case, we just did a simple RGB to grayscale conversion, and that made it a lot better. So these are good. So there's a couple of people just asking questions. Actually, I'm pretty sure when I've run through this, I did the two. The main accuracy comes from doing the RGB to grayscale translation. And it's interesting because as people, we want to see that we perceive the world in this RGB, this color world. But actually, when you look at things in the grayscale world, there's a lot more subtlety, a lot more information conveyed than what you think, and that provides a lot more information for the models to be able to work. So you see that a lot of times actually in applications. You see that a lot of time for these applications, you know, that working in grayscale is one of the first things you do, particularly for any image processing application. For a lot of image processing applications, one of the first things you do is convert it from an RGB to a grayscale implementation, and it gives you more information to kind of work with because you've got more contrast, more range across there to take a look at, and of course you've got the application. So it was the main. I'm not sure that making the squish actually makes a huge difference, but that grayscale, that RGB to grayscale makes a big difference. Somebody was just asking about how much RAM is usable for a single model out of the 1.5 megabytes. And let me just scroll back to where I did the software download, where I created the software download again. So in this application, we're using about 600K of the RAM for this application. So it's not too bad. So I guess you don't want to go too high, because obviously there's a limit. There's limits and other overheads as well. So yeah, so you did hear right. Mistakes. There are other frameworks running. Right. This one's actually running on so Nutex is one of the applications that framework operating systems actually that's supported. But this one's actually running pretty much. So you can see under this SDK that you download, there's the Nutex and there's the SDK. So off the top of my head, I'm not sure exactly what that segmentation would be, the maximum that you could use or not. But certainly we've used sort of, well, maybe just over a third of it today, and there's been no problem. So I would imagine that you could probably take it a little bit more. But if you want to drop me an email, I'll take a look and try and answer your questions in a little bit more detail if I can dig out some information. Is there any more questions before we wrap up this session? So if you're interested in taking a look at anything else related to the Sony S-Pens and such like, then there's some links there to check out. And if you've got one of the development boards, they're great to pick up and run with and use and take from there. I think it's going to be good fun. I think that honestly, Edge Impulse, it's really the nicest framework I've done for machine learning. And today, while we've looked at crops, the framework that we've done is just so flexible that that you can use it for particularly any application. So in the room today, we've got medical engineers, people interested in audio engineering and such like as well. So I think it'll be nice, and I think it's got a nice wide broad appeal to it. But apart from that, I'll wrap up there then and say thank you very much all to attending. And if you've got any questions, the emails are on my GitHub link.